So it says here if 5.43 grams of aluminum are reacted with an unlimited amount of whatever this is, Cr2O3, how many grams of aluminum oxide can be produced? So yeah, the first thing is you do have to balance the equation, which it already is balanced. So you start with the given grams, so grams of aluminum, okay, and you multiply by the molar mass of aluminum on the bottom here, so 26.98 grams of aluminum in 1 mole of aluminum. Okay, so that's how you read this number here.
Mhm.
Is that okay?
Yeah.
All right. Then from here, this is your mole conversion. So there's 2 moles of aluminum for aluminum oxide. So for 1 mole of aluminum oxide there.
Mhm.
So you should show it. You should say 1 mole aluminum, 1 mole Al2O3. Okay. And this is the main conversion. I mean, you have to get everything into moles basically in chemistry. I don't really know why, but that's what they do. So from here, you need the molar mass of aluminum oxide. So 1 mole Al2O3, and that's 101.96 grams Al2O3. Okay, so this is your calculation here. This actually looks like what you did.
Yeah, it was. I think it took off a point for significant figures,
Okay.
so it should have been 10.7 grams of aluminum oxide.
I don't know. Like when I'm looking at, so this has 4 significant figures, 5, 5, 4. This one has 3. So yeah, they want your answer in 3 significant figures. That's actually kind of, I'm surprised they're making such a big deal out of that. But yeah, I mean, your answer's right. I mean,
This is like.
go ahead.
Sorry, I was just gonna tell you that at West Point they like to hammer like this stuff right now, because like once we get down there, like they'll take off points for stuff like that that's very simple, and they harp on it because they're very attention to detail oriented.
Right. Well, so now you know. I mean, that's the, you almost want to make a sig fig chart to know like what are we dealing with, but I mean that everything else looks right there.
All right, on to number 3. This was something that I got pretty wrong.
Okay. Let me grab this here. What is GFPSR? Oh, given, find, plan, solve, reflect. Okay. That must be something they're really going after in class.
Yeah.
And you see this from time to time. You'll see this in statistics too. If you take that class, they tend to like emphasize this. So using the reaction of Cr2O3 is the limiting reactant when 12.2 grams of aluminum and 16.3 grams are reacted together. Based on that, how many grams of the excess aluminum remain after the reaction is complete? Okay. So like, did you get a clear depiction of what it means to be a limiting reactant or a
I know
non-limiting?
that limiting reactant means so like it's used up first, but I don't know how it's used in this context.
Right. So I just, if you don't mind, can I take like 2 minutes to talk about cooking and how there's what a limiting reactant is in cooking? Because I think it might make more sense. So if you've ever made, you want a bowl of pasta, and there's typically 2 ingredients. There's the actual noodles and the sauce, right? So if you don't have enough sauce, it doesn't really matter how many noodles you have. And if you have too many noodles, you just don't have enough sauce to get your bowl of pasta. So the limiting one is the one that like you really wish you had more of because you've got excess in the other. And this happens all the time when you cook. You just like, oh, we don't have enough sauce to make pasta. We got all this pasta, but not enough sauce, or whatever it is, milk and cereal. So try to think of it that way. Now, in terms of the actual mechanics here, what you're doing You start with the one, like they're being kind here and telling you the limiting one. Usually you have to figure that out. Okay, and maybe that comes in the next problem. I don't know. But we start with 12.2 grams aluminum, like you have here, and then we convert to moles. You always go to moles. Yeah, I don't. Yeah, that's just the way it is. And by three significant figures there, so your final answer of three significant figures. 26.98 grams aluminum, 1 mole aluminum times. Now this is where you got to do your mole conversion. Okay, and let's
So
see.
this one is do I put AL on the top and CR2O3 on the bottom?
No. So okay, so this is key. The thing that's on the top is going to go down to the bottom.
Okay, so AL is going to go there. Is it going to be the CR2O3 on the top?
No,
Right,
no,
yeah.
no. So this is. I'm sorry. I've started out with the wrong one. I apologize here. We need to start out with the limiting reactant because it doesn't matter how much aluminum it is. You start with the limiting one. So we actually want to start out with 16.3 grams of CR2O3. Okay, and I'll explain that in more detail in a moment. But you start with the limiting one. I was thinking we had to find the limiting one, but they've already told
Yeah,
us
we're
that.
giving it. Okay.
And I should have noticed that. I even said it, but so there's 152.00 grams CR2O3 and 1 mole CR2O3. Okay.
Okay.
Now this is where we need the coefficients here, and we got to figure out, well, which one are we going to go to? And the answer is it doesn't matter because the final problem doesn't have anything to do with one or the other. So it really doesn't matter is the
Is it 1 mole AL2O3 over 1 mole of
yeah,
CR1O3?
yeah,
How that
I
works?
guess we'll go there. Yeah.
Okay.
So that's where you're actually using the coefficients from the balanced equation. Okay. Now this tells us, and this is where you first want to figure out how many moles of the products you're going to get. So we actually need this calculation here. So if you got a calculator, if you want to.
Yeah, I got it handy. I'm doing it right now. All right, so 16.3 divided by 152. That's 0.107.
So I would go out a little further on I would go out like double the precision on intermediate calculations, like for in terms of like it's not asked for this, it's just an intermediate result. So I would, and hopefully, so I would go out a little bit more. Sorry, I'm just trying to get those significant figures now that I know what you guys are doing. So this is 0.107237 moles of the Al2O3. And the idea is, okay, if this is how many moles of this were produced using up all of the CR2O3, you go backwards to figure out how much aluminum you actually needed.
Okay.
Okay, now we could keep going from this equation right here, and that's how sort of the chemistry experts do it. We're going to restart though, because just to make this clean, Al2O3 times. So now this is where you do your mole conversion. There's 1 mole Al2O3 for 2 moles of aluminum. So again, the thing that's on the top goes to the bottom, and then there's 2 moles of aluminum up there. Now, because we want to know how many grams of aluminum, we have to convert from moles of aluminum, molar mass of aluminum.
So 1 mole of that to 26 or 52 on the top?
26.
Okay.
Yeah. Okay. Now, if it were Al with a subscript 2, then it would be 56 or double 50, 27 doubled. But this is like, let me try and do it in another color here.
Okay, so I'll take this number, multiply by 2 and multiply by 26.98, and I get 5.78.
Yes. Okay. But this is just what I'm doing here. That's the molar mass. The molar mass is always for whatever is there without the coefficient. I'm sorry. Could you give me that number one more time?
So 5.7865. 7, 8,
So
6.
779 then, if we go to 3 significant figures, grams of aluminum. Good. Okay. Now, so this number has to be smaller than the amount that they gave you, because you know that it just tells you, it says that there's excess.
Mhm.
Okay, so that's kind of a built-in check, like, did I do it right? You know, and if you're not sure, you need to know a few things. You're like, hey, I actually only needed 5.79 grams, but I had 12.2. Okay, so the excess here, the excess is 12.2 grams aluminum minus 5.79 grams aluminum. Is that okay?
Yeah, that's fine.
So
The
now,
excess is taking the, so it's the 12.2. Why
yeah,
are we taking this 12.2?
because so that's like imagine you had 12.2 grams of this aluminum just laying there,
Yeah.
and you didn't need to use them. You like, you threw them all in the reaction, but you didn't need them all. You actually needed 5.79 grams
Mhm.
of
Do
aluminum.
we, do we end up converting the 16.3 of CR2O3 in there?
No,
Oh, we already did. Okay.
that's where I went. That's going back to that like pasta and sauce analogy. Like you boiled all this extra pasta that you didn't need because you only needed 5.8 grams of that pasta. You just didn't. You had too much.
Okay, that makes sense.
Or milk. You had too much milk in your bowl. You only needed this much milk for your cereal.
So how much do you end up with the excess?
So you subtract 12.2 grams minus the 5.79.
All right, 12.2 minus 5.79, you get 6.41. And in this case, it should be 6.4 grams.
Three.
6.4,
I mean, I'm thinking 3 significant figures, so I would go 6.41.
6.41.
So a quick review of significant figures. You count
Oh, yeah, this is
everything.
the small one, the
Yeah.
smallest one. Yeah.
Leading zeros don't get counted, but trailing zeros do. So that 52.00, that's 5. But
Mhm.
leading ones don't count.
All right. That works for me. All right, number 4, I don't understand these types of, oh wait, no, I think I got number 4. Number 4 was right. I think it was, nope. I think it was, yeah, I didn't know what number 4 was.
The aqueous hydrogen permangranate.
Yeah.
Okay. So this is, this falls a little bit out of my like, this is not math related, so this is where I'm going to be a little bit less helpful. But the products here, aqueous and an aqueous. So I'm tempted to say here, when there's some aqueous stuff, is this an acid? This might be an acid. There's going to be some like hydroxide ions or water. Do you remember that at all from class?
I think so.
Okay. Okay. So let me do some quick searching here. Predict the products formed and label the type of reaction. I mean, you're on the right track with the types. I mean, there's, double replacement, single replacement, there's combustion, one other one. So let me see if I can be more helpful here with this.
This is the type of stuff where I just fall all the way out.
Yeah, understand. Understand these aren't H. See, I feel like it's going to be like a magnesium oxide, let's say show, but I don't know. MnO4 plus correction divide. Predict the products formed and label. What is this 1.1 referring to?
Oh, that's just the section that we did it.
Okay, any hints from that? And is that at all maybe?
I'll pull it out. Let's see. Balancing chemical equations. So the gas. Oh, I think I have a page from this of basic chemical reactions.
Any chance you could send that over?
I'll send it right now.
Yes.
Want me
Okay.
to send
So
it to you through text or through email?
whatever's easiest for you. So what I don't know, what I don't know is why this is the case, but you have to recognize that the H and the OH are going to form water.
Mhm.
And I don't know why. Like I can't say like, this is where my knowledge of chemistry is limited, but the Mg then forms with the other one.
Mhm.
Okay, so and the idea I guess here is that because the H is a plus and the OH is a minus, and the MnO4 is a minus, the Mg is a plus. I know it might be a +2 or +3, but like they have to pair up. Okay, and where you probably didn't quite know where to go is because you're used to just switching them, and you sort of are, but it's the Mg that goes with the MnO4.
MgNO4. Okay.
Yeah. Okay. Now let me look at what you sent here.
These are different types. Double replacement is bomb left. C.
Yeah. But this is one of those things where when water forms, this isn't a double. I mean, it is, but like you'd have to know that the H and the OH form water. I don't know how you would know that, but now that we have that down, you have to balance the equation.
Mhm.
But does it, because it just says to predict the products, does it, that implies that you need to balance it? Because I know that's coming up here.
I don't think it did require me to balance it. It just wants
Okay.
to. It just wants to see if I know how to do it.
So this kind of wasn't, I mean, the realm of fair, like all the ones you just sent over the double replacement, you literally take one with the other. Although I don't know why that first one's double replacement, because but like there's a second line there. See, none of these form water. Are you sure? So to me, it looks like set D is double replacement. And set C is single replacement.
Oh, I think I had this. Yeah, I might have it backwards. I think
Okay.
I never corrected that. That's probably true. That's probably right.
Oh, and there is one. So there, boy,
Is there one
again,
that's exactly like this?
kind of. It's really hidden. Let me grab it here, snip it in. So I'll just handwrite it. Things hasn't uploaded yet. So there's one in set D that's HCl, which is an acid, plus NaOH produces H2O from the H and the OH
Yeah.
plus the NaCl like that.
Yeah, true.
And that's buried. It's kind of buried in there. There's
That's
one
definitely
earlier.
good.
There's actually this one is in there. HNO. Well, it's NO3, not NO4, but it's the same idea. So this is a double replacement. You got that right. And normally you do take the positive one and put it with the negative one and negative one with the positive one.
So it should be H2O for the left.
Yes.
Okay.
And this one, the reason I was asking, like, if you need to balance it, which you might as well do if you're going to turn it in, there ends up being a 2 here and a 2 here. We'll get to that maybe.
Is it H2O plus MgN2O4?
Yeah, that right down here. Yep.
How come it turns into an M2?
Sorry, that's an MN.
And
Sorry,
then
that's MnO4. Sorry, bad writing.
that's fine. All right, so that should be 2 plus minus. Okay.
All right,
That
so
makes sense.
letter B or B.
Yeah.
Okay.
Oh wait, no. Oh yeah, letter B is true.
All right, aqueous lithium chloride reacts with zinc metal. So it's LiCl, and that's from your charges. Now, were you given a periodic table?
Yeah, we're giving it a periodic table. I
Okay.
should do my chemistry references. We get like a couple of pages to look through.
Okay, so this is the first mistake here is not recognize that Li is obviously in the first column, Cl's in the 7th, and I think you'd have to check, but that's why +1, -1, and then zinc is here. So now you're close here. I mean, you got to switch them up. It's one of these is going with this one, and so which is it? And zinc, I believe, is in the same column as, well, I'm not sure. Do you have one handy? Let me pull mine up here.
My periodic table.
Yes.
Yeah, I do. Which one do you want to look at?
Well, we want to know what zinc is, where zinc is in the table.
Zinc
So
is 2B.
2B is this, it's in the second column.
Yeah, it's in transition metals.
Okay. I need to grab one. Get grounded here. Where is it? You said it's in the transitionals. Which number is it?
It's
There's 30.
2B.
30. Okay.
Oh, 30, yeah.
Yeah. So what we know is that zinc's going to get paired with the chloride.
Mhm.
Okay, because this, this is +1, this is -1, and then now is zinc how do they telling you to know the charge of zinc? They saying 3.
I don't think you need to label the charges. They just need to see if you can do it.
Well, we need to know how many though, because it's never 1 zinc with 1 Cl. It's like 3 Cls with 1 zinc, because zinc is +3. That's what I'm referring to.
I always forget how you're supposed to know the charges of the transition elements.
Yeah, and then that's why I don't that's what I'm not sure about. But let's just assume for a moment it's +3, because that's sort of where it is.
Mhm.
I know they can sometimes take on different, let's see here, zinc metal form new. Okay. So then again, the idea here is okay, that's +3. Cl is -1 times 3. That's how you get that to match up. And then plus the one that's left over, the lithium. And this is a single replacement, because only one switches place.
Oh, okay. There's only one got replaced. That makes sense.
Yes.
All right, so it's aqueous solid, and then is it?
Yeah, done
solid
unknown.
aqueous? Unknown?
Let me go to this. I'm looking at this chemistry balancer. Let me see if I can give you an answer.
After this, it should go back to the math. It's oxidation reactions.
Okay. Please ensure it's correctly entered. LiCl. Is Cl not? Excuse me. So this is saying it is so I was wrong here. Zinc is a +2, not a +3, and it's a Cl2.
Mhm.
And again, see, this is where I'm not sure why. I couldn't tell you why that's +2 instead of +3. But the rest of this is okay. This goes with, there's 2 of those. There you go. All right. So you said this, hopefully that's good enough for this. All right, we're up to 5.
5 is correct. I just need to
Good.
look at
Good.
number 6.
6.
6
Oxidation.
Yeah, you can
Oxidation.
tell I suck at this one.
All right. Yeah, don't be so hard on yourself. I mean, this is I'm sure you're under a lot of pressure. You got a lot going on. Give yourself some grace.
Aw.
All right. Calculate the oxygen numbers of each element of reactants and the products. Got it. Okay. So you start with the stuff that you do know. Like H is plus.
Mhm.
Okay. So the it's 6+. That means the carbon.
Yeah,
I
I
mean,
had these wrong, I think.
yeah, I'm trying to think, like, because carbon's normally 4, but not in this thing. Sorry, I just need to look up something again here. Carbon 1, 2, 3, 4. Carbon's usually 4 though. Oxidation numbers of each elements. Okay, let me just do a quick search for an example to refresh myself because it's not making sense logically.
Yeah, that's why I need help with chemistry, because it's like it makes sense because it makes sense, not because it actually makes sense.
Yeah, there's not okay. Yeah, and this is what I was sort of thinking. So it does appear that so the idea is that the net has to be 0. So so we know that H is plus, like I guess you can go off of that and be like, all right, that's fine. So the C2 must be -3 to make
Okay.
it 0. Like that's what I'm seeing as sort of standard. Where it gets wonky is like, what do you do with an O2? Well, apparently it's 0. And I think that's because it's stable by itself.
Mhm.
Okay. And so now it's like, well, what about CO2? Well, carbon, like I mentioned, is -4 or +4. So it can go either way. All right. And that's where I think it's like confusing. So you got to look at like which one is more likely to take on one or the other.
So should the O2 be like +2?
So
Just
go
to
to
make
your
it
periodic
fair?
table. Go to your periodic table. See how O is in the column 8.
Yeah.
O is more likely to be -2, whereas carbon can be +4 or -4, depending on what you want it to be.
Mhm.
So that's that. So the decision's made for you because O has to be -2. So there's 2 of those that's -4. So the C is then +4.
So it needs to be, oh, okay, so I
but
had
it can,
this
but
stuff backwards.
yeah, you're close. I mean, because you're looking at C and it's like, well, why isn't it -4? Great question. H2O, the H's are plus, so the O here must be -2.
Okay, and so now I'm looking for the oxidation and then the, wait, so oxidation of the reactants and oxidation of the products. This is where I get tripped
Well,
up.
this is, we just answered it. So the answer here is for the C, the O, and the H of the reactants, we have those. The C is -3, the O is 0, and the H is +1.
Mhm.
That's it.
Well, I'm putting the original answers that I put for these so that can show how I write. So C.
So the sign matters, you have to be, whether it's positive or negative, and then the products, I believe it also goes CO, the order is COH again. Yeah, COH. So the C is +4, the O is -2, and the H is +1.
Eight. Real numbers should be -3, -3, 0, +1, or -2, 1. Okay. Let's see. All right. This makes more sense. What about for E and F?
What is the name of the element compound that acts as the oxidizing agent?
Oxidizing means that it's gaining an electron, right?
Need to look that up. I don't. So that's a good question. Oxidizing, is it gain or lose? Okay, so the oxidizing, here's the summary of it. Let me snip this in. Okay, so this is a quick find on Google here. The reducing agent, like I think you said, loses an electron. Oxidizing agent gains an electron. So they give you an example here. Magnesium is normally +1, but then it went to +2.
It looks like for carbon went from -8 to -4.
No,
So that one oxidized, right?
let's go back. So let's do the simple ones. So the ones that if they go more positive, that means they lost an electron.
Oh,
Okay.
okay.
Or I don't want to say this, it's not actually more positive, it's from negative to positive. So the carbon lost 7 electrons, which it's really, it's kind of startling. That doesn't seem to make sense, but that's the way this goes. And then if it goes more negative, it gains an electron. So the O here is gains 2 electrons. So based on this, the oxidizing agent is oxygen, and the carbon is the reducing. I hope that's different than what it is.
It's
Okay.
different.
Yeah.
And it makes more sense.
Okay.
I just have to review this before. All right, now this is all done with the free answer. Now this is off to the multiple choice stuff that I got
Okay.
completely wrong. I'm gonna tell you which ones are
Sure.
I got wrong.
Yeah, when I took chemistry, I had to do, note cards, constant review of notes. None of this made sense logically. So I had to like really study up on it to remember. And I've obviously since forgot so just keep that in mind. Like not everyone's blessed with naturally knowing this stuff.
So it looks like I got 3 and 4 wrong.
3 and 4. Okay, carbon.
And I have the
Dice.
right answers for these. So for 3, it's A, and for 4 is C.
Okay. So there's something about that di in front that's key here. Carbon, disulfide. So that means 2 of them. Okay. So the carbon disulfide means CS2. Reacts with oxygen. That doesn't oxygen gas. So you might need to know that gases are O2s. Could be liquid. Forms carbon dioxide. So you'd want to know that that's CO2.
Mm.
And sulfur dioxide. So that's SO2, like that. All right. So now see the only thing that I think could be problematic here is knowing whether it's O2 or O6. But I guess because there's so many O2s, you would say, okay, it's got to be an O2. All right, now the rest is just balancing. How are you with balancing equations?
Okay, that's funny. I didn't think that this would this is how it would go. So that should be CO2 over here plus SO2. So now you just have to balance it. This is a lot simpler than I thought. Okay, so
But how do you like to balance?
how do I like to balance it? I do like a
Yes.
little chart. I do like I'll put CSO on the left and then CSO on the right. And so I just look at what they have originally on the left side. So it looks like it has 1 carbon on the left side, and S has 2 on the left side originally, and O has 2 on the left side originally. And on the right, it looks like it has 1 carbon on the right side, and 1 S on the right side, and 4 oxygens on the right side. So now you get a look through process of elimination. You can put a 2 in front of the O2 on the product side. That turns into 4 oxygens. And now you just need to get the sulfurs to line up. But the problem is that
So if you put 2 there, that has to change the
Mhm.
number.
Yeah, I
Number
put
there.
2 there, and then the oxygen will turn to 4. Turn into 6 on the right. So let's turn it 2.
Good.
Turn it to 8. So on the right, you just put a 4. I think a 4. Yeah.
No, you've got it because you just said it. There's 2 oxygens and now there's 4. That's 6. There's 3 there. That's 6. You got the oxygens, and then 2 sulfurs, 1 carbon, 1 carbon.
So it should be 6 oxygen. Oh, okay.
Uh,
Wait, so
uh,
right from this.
Oh, I see. Are you adjusting your table?
Yeah, I'm trying to adjust the
I
table.
see. Yeah, so the table will now properly adjust with this.
And that should be C. What?
You said A.
Yeah, it should be A. Yeah, okay, okay, it is A.
Yeah. Yeah, I mean it's obviously seeing it a second time is not as tough as first time. Okay. Sodium metal and chlorine gas. So again, like I would want to know why gases are Cl2s. But I guess they are. So we got Na plus Cl2. Yeah, another way you can do this, like this is a testing strategy, is you look for the ones that all match. Like that's an indicator that's going to be one of those. Because they wouldn't want to make it so obvious. Reacts to form sodium chloride. That's where you're using your in fact that's +1 and -1 to form together. And the fact that it's an ide, that also tells you something.
Mhm.
So now it's just a matter of balancing. 2 there.
Man, I picked the super wrong one. I picked the one that NaCl2 does not exist.
That's right. Yeah. So that would have been another way to eliminate. It's like, all right, that's impossible. That's impossible. Same with that last one, actually, Na2Cl.
So it should be sodium metal is just Na, and that's S, and then plus chlorine gas Cl2. Is it
Cl2.
Cl2?
Yeah, and
Okay.
that's what I made a note up here. I don't really know why the gases are always in the twos, but they are, like O2.
Oh, that's that's it. Okay, and then it's just supposed to be C. And wait, no. Hmm.
Yeah, let's see, because you
Oh, then you have
need
to balance. You have to
you have to
balance.
balance. Yeah.
So now I have a table. So Na, Na, Cl, Cl. So on the left, I got one Na and two on the left. Right on two. So you just put a two in front of the Na on the right. And that turns into two Na on the right. And two Cl. And then on the left, you just put a two in front of the Na. And you get two. So two Na plus Cl2 goes to two NaCl, which is the right answer, which should be C.
Yes.
Okay. Okay, this is that's a lot easier to look at it from that perspective. All right, now
Good.
on to stuff that I suck at again. 8.
8. Got to be kinder to yourself, Jack.
I know.
We're our own worst enemy. Our self-talk is like bullying.
Yeah, it is.
And I'm no different than you. I mean, that is too. Just keep that in mind. I mean, enough bad stuff in the world. Give the balanced equation. Okay, given the balanced equation, yay. What mass of boron is needed to fully react with 10 moles of fluorine F2? Okay. So you start with the thing that they give you, 10 moles F2 times, okay? So you're already in moles. And you just want to go between moles, okay? So 3 moles F2, that's from here, goes with 2 moles of boron right there, okay? That just gives you the moles, though, of boron. You now have to use the molar mass of boron. 1 mole of boron is 10.81 grams of boron. And again, you've seen this before, but the units cancel out, like moles of F2, moles of boron, moles of boron. So it looks like it's going to be
10.81 grams of boron. Oh,
that's the molar
molar
mass.
mass. Molar mass of boron will mole B. There we go. Okay, so B can still get rid of the moles, and then you just give it. You're left with 8, which is supposed to be C, which is 72.1
1 grams.
Okay, on to number 9 and 10. This is stuff that I really need to practice.
Okay.
So C3. This is all math stuff, so I could just easily learn this.
Yeah, there's parts of chemistry that are really just math, but then there's the stuff we're doing earlier. So start with the given, 76.8 liters O2. Do you remember how to convert from liters to moles?
No, this is the particle stuff that I didn't know how to read.
So
I know
there's
2.2.4 liters.
of O2 and 1 mole of O2. You always go to moles, like it. Let me draw a little picture here. So here's moles, and here's grams. You can always go back and forth. Here's liters, and then these are just drawn arbitrarily. They're particles / atoms. Okay, and the conversions are 22.4 This one here is Avogadro's number, 6.022 times 10 to the 23rd. And then this one is the molar mass.
So why is it one mole of O2 that goes to 22.4?
Yeah, because a mole is like to me, a mole is like a dozen. It's a representation of a collection of something.
Mhm.
I'm not sure exactly what the formal definition is, but a mole is just a collection. It's like a standardizing. It's a way to standardize everything.
So what do you do next now that you've converted to 76.8 moles of
So
O2?
whenever you get to moles, you go back to the balanced equation, and you're here at O2, and you want water, so you're going to go 5 moles O2 to 4 moles H2O. So you're using your mole conversion, 5 moles O2, 4 moles H2O, and that's from the balanced equation.
So 4 mole of H2O on the top to 5 mole of O2 on the bottom. Okay,
Yep.
so now you're left with moles of H2O, and then you just use your calculator, right?
Well, again, good to write there. 1 mole of H2O is 6.022 times 10 to the 23rd particles H2O.
Okay, so now you actually do the 23rd. Now you do the calculator stuff. Let's see, so 76.8.
Thankfully, the answer is there.
And 22.4 times 5 is that is 112. So then you take this number, divide by this number. So you get 1.65 times 10 to the 24th, which is C.
Did you? Yeah, you got C. Good.
Yeah.
Okay.
Yep,
Okay. All right. So real quick here, Jack, just as we're about to close out here, because I don't want to, there's obviously a lot more here, I guess. How many more questions do you have?
So it looks like I got 1, 2, 3, 4, 5, 6, 7, 8, 9. Wait, so let me check. So I've done 1, 2. Wait, so 1. So sorry. Got lost a little bit. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9. I think 10 more questions.
Okay. So we'll probably have some time. So just keep, because I'd like to stop here. We'll take a short break, and then we'll reset with that new booking link and continue. But if you have more stuff, feel free to please send that over.
All right. Thank you.
All right. See you in 10 minutes. Okay. Bye.